So first of all, welcome everyone. Congratulations to survive to SUSECon, by the way. Hope you have fun. Presentation for today, beside that title, that I have this tendency to create super complex titles that doesn't mean really nothing, but no worries about that. No, the idea behind is really about, so we are all hear stories about, oh, let's do an LLM system. Oh, let's do an AI system. Oh, that's great. It's a shiny tool. Let's start immediately and etc. So my idea behind this session will be to say, okay, what are the things you have to think and consider when it comes to LLM? And I'm starting from here just to highlight one word in that title, that is inference. What I will say could be absolutely true also for fine-tuning and training system, but the idea behind is really about inference, because inference is translate basically in how do we put in production, a model. Because at the end of the day, whatever we do, it will end up into something that runs in production, and we need to consider carefully what we're going to run there. So I'm Alex, because Alessandro could be complicated. Actually, my real name is Alessandro Francesco, but I don't think you want to spend 3 hours just to say my name. So Alex is more than fine, more than welcome. I'm the senior product manager for SUSE. I tend to prototype and discover new things, anything, I'm not necessarily a nerd, or actually I'm a nerd, but on many things. Let's put it that way. I'm Italian. 2 words of advice. 1, 20 minutes or 40 minutes for Italian people are not necessarily 40 minutes for you. So it could be like 3 days. Warn you, I never stop talking. Second, if you don't understand when I speak in English, no worries. Follow my hands. Italians are made to use hands, so if I don't control my hands, sorry about that. This is a natural feature of the product, or a bug. So let's start from this. The agenda for today is basically about, let's start from an introduction. What an LLM system is, why size is important, how we can more or less size a system, and through some configuration. So, do I really know what LLM stands for? How many of you knows what LLM means? Large language models. That already means we're already talking about the wrong things. Because if it's true that LLMs is large language model, unfortunately, if you're going to implement an LLM today, you're going to implement probably a VLLM, a multimodal LLM. Large language models were the first kind of models, super large, that's been developed. It's basically just a model that is built to mimic humans in terms of language. You can understand language, you can understand the context, and based on the context, it gives you a result that is contextualized to your question. It's large because it's been trained with a huge set of parameters. So basically, you have a huge amount of data. You identify what are the relevant parameters for you to help the models to understand your questions in the end. And you use really huge amount of parameters in the order of billions. The smallest LLMs there are today are basically using something around 2 billion parameters. But the standard LLMs are over 70 billion parameters. That gives you an idea of how the LLM actually works. But LLMs are new 1966. Your new shiny tools, it's around since 1966. We are speaking about a new technology that had always been there, and you wonder why we did not use it. Actually, it's not that why we did not use it. It's that it went through a lot of discoveries, attempts, and things that actually made us working. ELIZA was pretty interesting. And if you look at the ELIZA prompt, it's not very different from what we do today. ELIZA is a mock Rogerian psychotherapist. Let's put aside that actually we use a psychotherapist as initial LLMs. That's another story. But I think fit perfectly the IT landscape at that point. And basically does exactly what you do today with an LLM. Of course, it was not an LLM. It was far, far, far away to any LLM system today, but was the first attempt. Then in 1990, we started to actually create statistical language models. And then we defined the network. The real game changer was about, whoops, sorry. Oh, there's a typo there. It's not 2027, it's 2017, sorry. It's all you need is attention. Now there's this trend in the IT market that seems like we have clearly problems with everything, like from psychotherapists to attentions, but anyway. Transformer models actually change completely the landscape. In a really simplistic terms, what actually they change is that they basically create a shortcut in the training life cycle. So we don't basically need to train anymore the model. We can fine tune the model. And that basically started to release models that we know more. But again, we are speaking about a technology that look at the number of new large language models being released in basically in the last 5 years. We are at the pace where every day a new model is going almost to be released. And that poses a big problem for us. The problem that is part of this session is not security, it's not about compliance, it's not about trust, it's about what kind of system we need to run this system. What we need to consider, because that is a cost for us. It's not about cloud or on-prem, it's about whatever I run, it will cost me. It will cost me a lot of money, because if I size the system in the wrong way because it's too small, it will not run. If I size the system because it's too big, I will pay too much. I need to find the right numbers. Okay? So, again, a large language model is a type of AI. That's poses the big question. In your company, the AI cluster or the AI machine are only focused on LLMs, or they're going to run other kind of machine learning? Are you going to share those machine learning? Because that's another consideration you have to have. That's actually it's just part, is a technique, it's just part of the AI landscape. And it's keep changing. We move it from pure textual large language system to visual large language system to multimodal large language system, so they can consume almost any kind of data, and we keep adding there. We're starting to observe hybrid models where we can combine multiple models at the same time. And since in IT we are not really good at fantasy, probably in 6 months we will probably get something like federated large language systems or stuff like that. So how it works? So that is a really simplistic way to look at the LLM cycle. So basically, a user starting clockwise from top left, in my case, top right for you. User asks a question, simple as that. Somehow the LLM received the input, need to evaluate that input in the concept of what we call the system prompts and the tools that it may have, because it's a multimodal. Again, how many of you knows what a system prompt is? Okay, couple of. So a system prompt is just a way, again, in really simplistic terms, to tell the LLM, tell the model, how it should behave when you receive an input. Now, typically that is the part where we do, during the prototypization, crazy stuff like, you are Harry Potter and you have to answer me in Harry Potter style every time. But in more practical terms means you can define an initial set of rules so that the model can contextualize even better the kind of input it will receive. Tools that are more recently are a way to say to the LLM, if you don't know, because still you have been trained on a defined set of data, if you don't know, you can use this tool to consume data from something else and figure out. That is where things become interesting, because it means that your system can make a plan looking at the tools that it has at its own disposal and use them and make it even more unpredictable in terms of result. Now, in our case, that start to appear, it's really important because that means that it creates an answer based on the findings, resonate, and produce an output. in two ways, or streaming or sequential. We will see what it means. But that means maybe I simply ask, what time is it? It can answer me with just the time, or it can answer me with a really long description of why it is the time it is. This will be super important for us in this consideration. And then the user finally receives an answer. And there are a couple of questions there, right? What are the sources that my LLM at its disposal? How many tokens, and that's the important part that we start to pitch, the token that are in the output phrase. A token is a way we describe the information when we look at the phrases. And we start to underline a message. Tokens are relevant about the input, how long is your phrase in a really simplistic terms, but also around the output, because both of them consume memory and consume informations. And finally, how long the user may wait. That is the most important part for you. Why? Because when you will release your nice chatbot to the company, we show the chatbot to your CEO, and the chatbot requires 3 seconds to reply, the CEO will look alike and say, well, it's impossible to use. It's 3 seconds. I cannot wait 3 seconds. I want to have 3 milliseconds. And the problem is not the LLM. The problem is that it's consuming a database, and the database is on the other side of the world, and your network is not very reliable, you're done. Or maybe it's just because you say in the system prompt that it should reply like Shakespeare, and so every time you give you a prompt as a release that is like 300 lines in basically unreadable English, and that's absolutely a beauty, but it takes a little bit of too much time to reply. So why size is important? I just say that. Size is important for many reasons. Let's see some of them. Whoop. First of all is the challenge you have to solve. And the challenge you have to solve can be summarized in one single question. That is, how many systems do I need to solve all of this? Is enough just a single LLM? Do I need to connect the LLM to different systems? How those systems are related to each other? What the LLM need to build internally in order to make the response available to me? And then means how long it takes. Now, it seems like a weird question. How long it takes? We have to build an LLM system. I don't know how long it takes. And that's a question for you. What's your expectation? What is the expectation you have? Because I'm speaking about chatbot, but chatbot is just one of the many ways to consume an LLM. Maybe you plug the LLM to your ticketing system. And the ticketing system should look at the ticket, understand what the ticket is, consume the historical data you have, consume knowledge base you have, figure out the best way to reply to this ticket, and maybe also suggest a possible response to the ticket. How long it takes in your company to reply to a ticket from your support? Is it 1 hour? You have a SLA in place. Is it 1 hour? Is it 10 minutes? Is it 3 seconds? I'm sure that in this audience, we all use the same trick that the moment the user sends a ticket, we get a reply that, hey, we saw your ticket. You are priority number 1 for you. No worries, we will get back to you. And we all know actually that this is just a workaround to give a perception to the user that actually we covered the problem, but actually we have tons of problems to cover before that. But it's exactly the same stuff. Is how long it takes, you have to reply within the SLA you have. It's a rule. You cannot change it. This is your rule. It's not a chatbot. It's just a system that provides an answer and need to reply in that time. So let's start to deep dive into that. There's basically 2 ways of looking at that. There's the pre-fill section and there's the coding section. The pre-fill section basically is the prompt and the user prompt. It's the combination between the prompt from the system and the user prompt. Basically what it does is try to figure out the context of actually the entire phrase. The context means user is asking a certain kind of topic. It generates a song, right? The decoding phase is the way the user writes. And this poses a slightly problem for you. Are your users trained to write proper prompts when they use your system? Or is the ticketing system, the ticket that we were seeing before, written properly? And the answer is no. Not because you are not training the user, because it's unpredictable. We are human. I can optimize a prompt, reducing to the list. For example, how many of you use an LLM, any LLM, OpenAI, etc.? When you write to the LLM, do you say hi? Do you write like if you are writing to a human? Because actually, it's not a human. It doesn't care if you say hi. Don't be gentle with him because it doesn't care at all. You can simply just give him the information. That's all he cares. Don't say, hi, can you help me today with this? It doesn't care. I need support, ticket, support, problem. That's it. It's a prompt optimization. Now, there are tools to optimize the prompt. And now, close enough, what they do is just look at your phrase, remove all the unnecessary things, and just give the prompt as it is, so the LLM perform better. That's part of your consideration. In your design, you can potentially implement a prompt optimization tool just for that reason. But we are humans. If you use OpenAI, or you use Gemini, or you use Copilot, I'm pretty sure you don't care about if the prompt is long, is short. You only care about one single thing: how long it takes. So, could you please me with some specific for your... Could you? No, thank you. Help me with specifics. But this creates a token. So the pre-filled are 5 input tokens, those one, plus 33 output tokens. Could you please me provide with some specifics? And they require 1.14 seconds to pre-fill and 1.62 seconds to decode. That's your time. And then you need to get a response. That's your first problem. So let's play a game. Where is your system running? I said I've stayed pretty high level because sake of time, because it otherwise become too complex later. But where your system is running? Is it running on-prem? Is it running on cloud? Because there are two things that can impact you. On-prem, it's really about size and capacity planning. Because on-prem means there's no escape. That's your hardware. It cannot do faster than that. That's all you got. You can scale, sure, but I'm pretty sure you cannot convince your company to spend $3 million of a system just because maybe will not be enough. And on cloud, you can scale, but token counts. Because close enough, how do you pay an LLM system in the cloud? Tokens. Did you train your user? No. And at the end of the month, you receive a bill that says, we have to send a note to the entire company and say, please stop asking the LLM how it feels today, because it's not really something that we need to do. But trust me, there's many people that do that. So it's more flexible. Cloud definitely is more flexible because we can scale. We can change the GPUs. We can scale everything, but it costs. It comes at a cost. On-prem is less flexible, but definitely we can identify or predict the cost. I'm not saying, and I just want to make a clarification, I'm not saying that one is better than the other. I'm just saying those are a couple of things you need to consider. Second is, how do you want the answer to come through? Do you need to stay in front of your terminal waiting for the answers and get a result? Or do you need the answer to come through like if it was human typing? And now probably you understand why some of those chatbots have also the audio of someone that is typing. Because to give you a perception, we are human. We need human interaction. The LLM is built exactly to that, to mimic a human. So if I give you a streaming back, it seems like someone else on the other side is replying. And you can say, well, who cares? Well, actually, it's in production. But if you remember a couple of years ago, Google did a demo during their conference where they were calling with an LLM system, they were calling a shop and it was a restaurant and making a reservation for the user. It's not 10 years ago, it's like 5 years ago. Nowadays, we do this on a regular basis. I can ask Siri, I can ask whatever system, chatbot, OpenAI, etc., to make a call for me, call a human, mimic that my behavior, say to the human that I want to make a reservation, and the human on the other side will never notice it. Why? Because it mimics the human behavior. Unfortunately for us, streaming is pretty expensive, because in this situation, only the time to first token matters, because we generate text faster. So it means that the moment you ask, you won't immediately start to answer. But that means also that the system needs to be powerful enough to keep pushing the data. Otherwise, you will see the first token really quickly. And if we have time, I can show you a practical example of that. And then you will stay there for seconds, waiting for the second token and the third token, and things becomes really annoying. In the sequential case, instead, you start the questions, it will figure out the answers, and once the answer is complete, it will push the answer to you. Again, same perception, same problem. You don't see immediately the answer, so you don't feel the perception is low, but maybe you wait too many seconds and you need to reply. So this is the first consideration you have to do again. Do you want a streaming, do you want a sequential? Are your user going to accept to wait for a second or two and get the result completely, or they want that human perception of someone that is typing? Because it impacts your streaming request. So let's see and let's play a game a little bit. So most of the models, this is changing already, but let's say most of the models support 4,000, more or less 4,000 tokens. This is basically the context window. It means that's the window I can consume between input and output before I need to generate a new input. So that means you wait more. So if everything stays within the 4,000 tokens, you got an answer. Otherwise, he has to do again the same context window. Context window can be changed, can be optimized. So if that is the default, you can shrink them, or you can try to use as much as possible. Why you should shrink them? Again, performance reason. And we will see that are related, by the way, on the memory you consume. New models can have larger context windows now. Things are typically degrade and become more complex. Unfortunately, we choose the wrong job. Things become more complex instead of become more easier. Everything counts. System prompt is a part of the tokens, and you have to include them. Retrieved documents, retrieval documents are part of the counts, because again, they generate prompts. Key paragraphs from an internal document are added to the prompt. We get the system prompt, we get the user prompt, I take the document, I create the complex, this enlarge the windows, I finish the Windows tokens, I need to generate another one, and you're still waiting. So for a 4K context means 3,500 input tokens plus 500 output tokens on a more or less case. So you're already done. Example, I love SUSE and want more. It costs you more than 9 tokens. System prompt say reply in a friendly tone, add a 5 token to add. Use some, you start to do. Your problem is, you have no idea how your user will go to use that. This is why, hi, hello, how are you doing today is not really something we want to have in our LLM system. So let's use a rule of thumb. In inferencing, again, in inferencing, not in training, in inferencing. How many of you know what inferencing is? Okay, so for those that don't know exactly, inferencing means once you train the model or fine-tune the model, you have to serve the model against the real data. That is inferencing. You infer the model toward the real data. It's true for any machine learning model or any AI model, let's say deep learning model. Means if you do computer vision, you train the model against pictures or video streams, the model more or less is trained, you infer the model toward the real data, so to data that you've never seen, and you react. This is where the model tends to drift. So This is a cat, this is a dog, this is a cat, this is a dog. It's really great, a cat and dog. You put the model in production, you infer the model, and a gecko comes in. And I have no idea what it is. That is a twist. So you come back and say, this is a cat, this is a dog, this is a gecko. This is a cat, this is a dog, this is a gecko. And then when you infer again the model, we say, oh, this is a gecko. Thank you. Here is a little bit more complex, but more or less apply the same rules. So can you calculate the GPU, but not necessarily GPU, the memory? I say GPU more because it's a context. We'll have a discussion on this. But can you calculate the memory that you need to infer a model? Yes, you can. Keep this with a grain of salt. This is not your silver bullet in the LLM system. This is not the super precise. This is a high-level algorithm to give you at least an idea of how to size things. There are more precise ways to do it, but just to give you an idea. And keep in mind that any hardware vendor has his own version of this rule because they can be even more precise. So memory is given by the model parameter in billions, by the quantization of factor bytes, means how do you shrink the model so that the model can perform better. But the more you shrink, the less is precise the model. And typically it's done by this letter, by the Q. When you see a model that is underscore Q, this will give you the quantization, and give you the quantization in order of bytes. 4, 8, 6 bytes, or 16 bytes. 1.2 is simply a rule of thumb, is add to the result 20% of overhead, because whether you like it or not, you have to load the data in. So if you look at this, basically you can calculate more or less how much memory you need to execute a model. Do we know this? Okay, let's start. If I look at the models, and I can show you live later, you will see that models comes with a number and a B. Those are the parameters. 2B, 2 billions, 70 billions, 100 billions. That's exactly what. A parameter is nothing more than the list of things that are valuable for me when I design the model so the model can be trained. I have this huge amount of data. I identify the parameters that are relevant to me to explain the model how to apply. And basically, it basically match the content of the data with the parameters. It basically creates a huge graph of information. It's a vector. Large language models are trained against billions of parameters. But that is important because the billion of parameters give you the idea of the size of the memory that is needed to run a model. So if I do a simple rule of thumb, then I say that the minimum GPU memory for Llama 3.1 with 70 billions will be roughly 168 gigabytes of GPU RAM. That's the size of the RAM that I need at my disposal. Now, is it this a single GPU? Is it multiple GPUs? Is it outside of the GPUs? It doesn't matter. Those are other considerations that we are not taking account here. It simply says that's the size I need to operate the model. Because whether I like it or not, it will require me that size. Again, to clarify, it's not how much memory you are consuming in a given moment. It's simply the maximum size of things you need to do. If you instantiate, if you infer a Llama 3.1 on a system, you do nothing, it is not consuming under 68 gigabytes of RAM. It's consuming basically the minimum amount because it does nothing. But the moment you start to write, it will start to consume the memory. And the moment you start to apply that, it will start to go there. That's the minimum you need to have because you already know that otherwise it will not stop. It will simply slow as hell. And I will give you a representation because I'm running some models here on my machine. And my machine is not exactly, let's say, a data center machine. And you will see that if I run a model that is 7 billion versus a model with 2 billions, you will see that actually the performance is really different. And by the way, I have no GPUs here. So GPUs are another things. Don't assume you need GPUs necessarily. GPUs is valuable because it separate, it offload the memory requirements from your machine But it doesn't mean that without GPUs you cannot run a model. It simply assumes that it's faster, it's optimized, is used by only the GPUs. But if you don't have GPUs, but you have enough RAM, you can potentially run the same model. So, but where do you run this? Okay, so we said, I can calculate this model, I can do this, I need a system. Now, this is my 30-second of marketing slides, but actually, I mean, they're for a reason. I put this slide here not to do marketing. I put this slide here to explain you something that you heard in the last days. What is SUSE AI? And people are saying, okay, is this a product? If it is a platform, what I mean a platform. You run this on an OS, on a Kubernetes, and on AI tools. And those AI tools are relevant. And in fact, now you know why there is inference engines as part of a component of SUSE AI. What we do, we put ourselves in an agnostic way to give you all the inference engines you can run from upstream, from open source, and say you can pick up whatever you like, because you choose the inference engine that is faster for you, that it applies better, because your model can run on one, but not necessarily can run on another. We help you to size in the LLM, etc., and we put you in a position where you can do what? Understand if your sizing was correct or not. Because we said, okay, I need 168 gigabytes of RAM. Great. Now let's show me. Show me. I want to see it. Show me actually that the model is optimized. Show me actually that it does. Show me that I don't have to wait 3 seconds. Because my user called me and said, I'm waiting 3 seconds for every single answer. Show me. Of course I can. Because I'm using observability. I have a topology that tells me that my LLM is actually connected to a database, and that database right now is down. So the LLM is smart, but it's not really magic. I never said we got Batman LLM. I just said we have an LLM. That's it. I mean, we can make things. So if I have a way to look at my system in an agnostic way, and I can see the information there, then I'm basically start to become things really interesting. So basically, what I'm saying is, this is a Olama within the concept of SUSE AI that basically actually is trying to listen me. As you can see here on top right, on top left, well, top right for you, CPU 1%, memory 8%. And as you can see, I also can give you the session about how the presenter is killed itself and survived. That's the second part of the presentation. Whoa. Typically, okay. Oops. Okay, let's do this. Let's see, otherwise I use another. Oh, okay, well, apparently not. Let's use a different system. Okay. So what I'm going to do is really something simple as, oops, okay. Oh, shit. Something like, oops, as usual, sorry. What I'm going to do, okay. You see it changes a little bit. I'm starting to interact with the model. It's not doing nothing yet. I'm going there and say, as usual, hi, how are you today? Oh, sorry. Oh, anyway, how are you today? Do you know anything about my pods in the cluster? Now I'm going to go hit and switch on the other side, and you will see actually that the first thing is actually that the model is doing, it's starting to buffer and calculate the context window for me to understand how much memory you need to actually consume from a minimum to a maximum. How many graph nodes he has to compute to understand the answers. And then he started the model. So basically, let me do this. What it's done is basically starting. When you see API chat, it means that actually the system basically replied to me. You see there that actually it says model parameters 3.21 billions, 186 gigabytes just as a model size, and basically go there. That means that on the other hand, that's what I received. He called the tool, he ran a Kubernetes, right now probably failed because of a security certificate, but he tried to sue it. It looks like the tool was unsuccessful. This is the LLM reply me, oh, your tool is not working. I'm lucky that he's telling me that, but actually, he's literally saying me, yeah, of course you can. And my problem is not LLM right now. My problem is that exactly what I was saying before. My problem is not there, it's somewhere else. And in fact, in a really stupid way, if I'm still there. If I simply do something like that, because this is basically it's just nothing more than a stupid example. Let me do this again. Whoa, oh, sorry. Didn't mean to do that. If I go back there, and I said port status, it start to replicate, the model start to increase a little bit his information, he reply API chat, I go there, it called the tool, it figure out all the pods that are running on my Kubernetes cluster, and as you can see, reply again, and my model now gave me the status of my pods in the cluster. Now I have a service, now I have an agent that replied to me, it served to a use case and makes sense. And as you saw, I have no GPUs, I have no really great stuff, and etc. Now, I don't remember which model I have planned. Let's see these quickly. I'm using Terminal just for sake of a demo. I could use directly the interface from OpenWebUI and etc. It's just a matter of I pick up any tool from SUSE AI and using the tools just to consume it. You are free to choose. So let's see what model I have there. Okay, I only have Llama. Let's say that I want to pull a new model. Should be this one, I think. So Ollama, basically, in the nature of Ollama, I can pull any model. Put aside the security context here. There was another session, but happy to reply to your answer about should user allow to pull models? They should not. So basically, we'll download the models if we have time. We almost run out of time. But basically, we pull the model, we run the model. This is a 7 billion model. It's bigger than the other one. The other one is it's roughly 4 billions. This is 7 billion. So if I run the same strategy, the same approach, using that model, you will see that actually my CPU start to raise, my memory start to raise, and we start to slow down. Even if I'm using the minimal environment, I'm not using any user interface, I'm using a terminal, I'm trying to do everything as minimal as possible, okay? Well, while we're waiting, come back to that. Let's see again this one. That's why observability become a key point for you. Like Ron Nguyen, that is the other PM of SUSE AI, was saying the other day in another session, if the AI components is a choice of yours, so it could be chosen and you can replace it anytime. That's why we put all the components there, we put as much as possible components there. Observability is unfortunately a mandatory requirement. Not because we want to sell you observability. Observability is a requirement in your infrastructure. You need to know what things are doing and where are doing things, especially with regards of AI. So conclusion, while we're waiting, then I will back there. Consider the average count of token. That means consider the average count of token that your user will use. I know it's really tough, but when you plan an LLM system, you have to think about how my user typically write. Do an analysis, do training. Train the user to string them questions. Explain them that they are not talking to a human. Consider also the expectation in terms of time to respond, sequential versus streaming, and consider also the kind of information that the LLM has to consume, because it adds information to you. When I showed before that it can give me an answer like, these are the posts you're running, you have to consider that those are all tokens. That's the token. It has to create that information. It has to add this information in the output. It consumes memory for that reason. So consider system prompts and external sources. And again, if you don't see, you don't know. So with that, in the meantime, and thank you for listening you. I basically make it almost in time. That is almost a record. Probably tomorrow we know. If there's any question, I'm more than happy to answer your questions. Or for those that are curious, I'm going to reply almost the demo in a few minutes, since we're finished. With that, if there's no other questions, enjoy the last part of SUSECon. It's been a pleasure to be with you all these days. We hope to see you again next year, if we survive, but that's another story. And safe travel back to those that are traveling, especially those internationally. It was really a pleasure. Thank you very much.